So remember in this lesson, we've been talking about triangles, types of triangles, the sum of angles in a triangle, how we can find the missing side in a triangle if we know two sides using Pythagoras, or a squared plus b squared equals c squared. Another thing we did with right triangles in grade 10 was, what if we didn't know two sides? What if we only knew a side and an angle? Or what if we were asked to find an angle given a couple of sides? Well, this is where trigonometry came in, okay? And trigonometry allows us to find missing sides and angles in right triangles. So if you remember the three trig ratios, sine, cosine, and tangent, okay? And in order to use the trig ratios, you have to be able to name the sides of a right triangle correctly according to one of the acute angles we're doing. So if this is the angle we're looking at, and that's the Greek symbol theta, if I were to draw an arrow out from this angle until I hit a side, the side I hit is called opposite. Okay? If I were to draw an arrow out from the right angle until I hit a side, that's going to be the hypotenuse. And then the third side is going to be called the adjacent. Okay? So like if I said this, I gave you this. What's the name of this side?
Adjacent.
Really?
No, opposite.
Opposite. What's the name of this side?
This is adjacent.
Adjacent. What's the name of this side? Hypotenuse. Good. Okay. So knowing the three sides, we can use these three trig ratios. The sine of any angle in a triangle, one of the acute angles, is always the ratio of the side length opposite the angle to the side, or to the length of the hypotenuse. Cosine is the length of the adjacent over the length of the hypotenuse. And tangent is the length of the opposite side over the adjacent length. And so when we get trig questions, one of the first things we have to do is we have to figure out what trig ratio we're going to use. And remember, we learned this way back when to help us establish what trig ratio we're going to use. SOHCAHTOA. The SO means sine is opposite over hypotenuse. The ka is cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent. Okay, so how do we do these questions? We set up a trig equation and we use algebra to solve. So in this question, I'm given this angle and this side. And I'm asked to find this vertical sideline. In relation to the 35-degree angle, what's the name of this side? What's the name of that? Opposite, adjacent, or hypotenuse? Opposite. Sorry, I didn't hear you. What's the name of this side? Hypotenuse. Which means, what trig ratio do we use? Sine. So how do we set it up? Sine of whatever the angle is, and what's the angle? 35 degrees will equal the opposite side length, which in this case is called A, over the hypotenuse length, which we know is 15. And now it's solving an equation. How do we get rid of the divide 15? How do I get rid of divide 15 to get A by itself?
Minus 25.
times both sides by 15. Because times 15 divide 15 cancel each other out. So that means, what do I have to do to calculate A? I have to, on my calculator, do 15 times the sine of 35 degrees. And remember, you should have a calculator. It should be in degrees all the time. We're just going to do degrees here. 12. Why did I put 15? Thank you. Right, that. Well, why I had 15? Yeah. So sorry, 12 times the sine of 35. And 1 decimal place will be fine. So using your calculator correctly, you should get 6.9 meters rounded correctly, 1 decimal place. Okay. All right, let's look at another one. Again, you've got to figure out our trig equation first and then use algebra. So in this question, I'm given the 58-degree angle. I'm asked to find the length of the hypotenuse. Well, the hypotenuse is PQ, so I'm just going to call it X. And we know that this is the hypotenuse. What's the name of this side? Adjacent or opposite? Adjacent. Which means what trig ratio am I going to use? Cosine. So I've set it up cosine of whatever the angle is. In this case, it's 58 degrees. Equals the adjacent length, which is 8, over the hypotenuse length, which we solve X. You with us?
Yeah.
Come on. How do I get rid of divide X? Times X. Times X. So what does it look like? X times the cos of 58 degrees is equal to 8. Well, X is still not by itself. How do I get rid of that times cos 58? Divide both sides. Divide cos 58. Divide cos 58. So that means my answer is going to be 8 divided by the cos of 58. So now I'm ready to pull out my calculator, do the calculation and round to 1 decimal place. We should get 15.1 centimeters. Okay. The final example with trig, okay, notice that in the first example, we were trying to find a side and it was on top in the trig equation. Second example, we were trying to find a side and it was on the bottom. Third different type of example when we use trig, what happens if you're asked to find an angle? Well, in this case, we're asked to find angle A. So I'm just going to call it theta. You can leave it as capital A, but I'm just going to call it theta. And you set up your trig equation again. What is the name of this side here? Opposite. What's this side? Hypotenuse. Opposite over hypotenuse means sine. So sine of the angle is equal to the opposite side over the hypotenuse. Do you remember what to do now when we find a missing angle? We do the sine inverse. Because I have to cancel out sine. Sine inverse cancels out sine. But that means I'm going to find the sine inverse of the right-hand side. So to figure out my angle, I'm going to do sine inverse 8 divided by 16, which is going to get me 30 degrees exactly. Okay. So you need to be familiar with how to do those 3 types of trig questions. Okay. And it should be pretty straightforward because, like I said, we did this in grade 10. We reviewed it last year.
Something we haven't really talked about in the past, although I don't know, maybe it was done in middle school.
There's a couple of the formulas you need to know. If you take any polygon, any size, 4, 5, 6, 7, 8, 9, 10, 20, 30, 40, you can always create a number of triangles by drawing segments inside. So how many triangles could I create if I drew a segment inside? 2, right? So if it's a 4-sided shape, I could create 2. Well, I know that the sum of these 3 angles is what? What's the sum of 3 angles in a triangle? 180. What's the sum of these 3 angles? 180. So together it must be 360. Right? So all we have to do is 180 degrees plus 180 degrees is 360 degrees. Because these add up to 180. These add up to 180. So all the angles together, the interior angles, must add up to 180 plus 180. Remember, 4-sided shape, you can make 2 triangles. How many triangles do you think you can make in a 6-sided shape? Well, here's 1.
4.
Here's 1. Here's 1. 4. Notice that the number of, what's that?
You can also do it from.
Yeah, you could have drawn them different ways. Like here, I got 1, 2, 3, 4. I could have done 1, 2, 3, 4 like that.
No, you could still do 1.
Well, no, but this is the minimum number of triangles. Okay. Yeah, I mean, you're right. I could make more. Like I could go like this and make more, but then I don't want to have to make more. I want to try and find the minimum number of triangles. So the minimum number of triangles I can make is 4. Each one is 180 degrees. So times 4, that means all the interior angles in this hexagon add up to 720. Because I just do 180 times 4. So remember, if it was 4 sides, I could do 2 triangles. 6 sides, I could do 4. How many triangles do you think I could do with 7 sides without having to draw it? 5. How many with 9? 7. See the pattern? 2 less. So from that, we can get a formula. We take the number of sides minus 2
times 180 degrees, where n is the number of sides. This is something you don't have to worry about putting on a reference sheet because you will get this on a formula sheet always.
So that formula saves us time instead of having to draw the shape, draw in the minimum number of triangles, and then calculating from there.
Final thing we're going to look at are triangles, polygons.
Oh, let's do this example first. So how would you find the sum of all the inside or interior angles in a 10-sided polygon?
What would you do? 10 minus 2 times 180. That's right. You get 1,440 degrees.
So again, that's better than having to draw a 10-sided polygon, having to figure out how many triangles, and then going from there.
Now, the last thing we can do.
Yes, that's right. And that's part of the formula. So if I take any regular polygon, remember what regular means? All sides the same. You need to know that. I can take the center of the polygon and draw triangles out from it.
So like this pentagon, 5 sides, I can draw 5.
Equal angles that come out from the center.
If it was a, sorry, if it was a square, not a rectangle. Has to be a regular polygon. Put a point in the center.
I could draw 4 equal triangles, same size and shape. Okay?
5, you see there, if I did 6, so a regular, it's not perfect, but how many triangles could I draw? 6.
Out from the center.
And you're right, the sum of these 4 angles, or sorry, in this case, these 5 angles here, these 4 angles here, these 6 angles here, will always be 360 degrees.
Because it adds up to a complete circle. How do I find each one? Just divide by how many triangles there are.
In which case it's 5, which happens to be the number of sides. So the formula to find the measure of a single central angle in a regular polygon will be 360 degrees divided by n, where n is the number of sides. Again, this is not one that has to go on a formula sheet. Or sorry, that has to go on a reference sheet because you will get this formula always.
So just as an example, to finish this off, what's the measure of each central angle
In a 12-sided polygon, 360 divided by how many sides? 12. Which gives us 30 degrees.
Okay. So the reason I wanted to stop and have a test here is because, I mean, those first 4 lessons contains actually quite a bit. Okay, because we talked about different types of, like we talked about polygons in general. We talked about specific types of polygons, like quadrilaterals. We talked about specific type of quadrilaterals. We talked about parallelograms. We talked about triangles. That's a lot of information. Okay. All of you should have a test review sheet or test review exercise. No, I didn't have it. Oh, I didn't hand it out. Okay, I will. That's right.